So, thank you for joining us. I'm very pleased to announce the first speaker today in this session, Antti Kemppainen from VTT. Antti will talk to us about advancing printed and hybrid electronics from concepts to pilot factory manufacturing. Antti.
Thanks, Karim. Yes, that's correct. My purpose is in this talk to discuss about that how to make the upscalability of the printed and flexible electronics and what kind of role the pilot factory can play on this. First, just a few words about the organization I'm presenting. It's VTT Technical Research Center of Finland, and like the name says, it's a research organization and about 2,400 employees. And very multidisciplinary. You can see the business units there on the right. We are part of digital technologies. What comes to printed electronics, printed flexible electronics, we have been working that for quite a long time with a group of 100 persons on average for 20 years. And what is our role here? Is to be the kind of bridge the gap between let's say the concepts, academic research, and the really upscaled commercial production. And our tools here are the R&D services that we do from the design to the process development, but also especially the work in the pilot. The purpose of the pilot factory means that we have a versatile machines, facilities, and competence to use these, that you can save time in the upscaling process and also de-risk your investments because you can try these processes on the existing process. The key things that we work on, it of course depends time-wise, but the diagnostics is one of the kind of biosensor applications is a thing that we have been doing. Here we work actually from antibodies to the printing and manufacturing process to readout devices, whether optical or electrical devices. Wearables, definitely, I will speak more about that, and these definitely are linked. Diagnostics in future can be integrated in wearables, for example, sweat sensing and so forth. Then there are some applications on integrated electronics, structural electronics, plastic integrated, or smart devices integrated to different surfaces and large area, enabling large area applications. And IoT is kind of recovering. We do more and more projects related to the kind of smart logistics, smart packages, and so forth. But then how do we do it? So this is a kind of simplified picture showing that basically the printed hybrid electronic process is having three major phases. So we start in printing. That in many cases after the concept phase is in rotary process, continuous web and quite high throughput. Secondly, we have a lot of capabilities on the conventional microelectronics chip assembly, pick and place processes, and that's done in the stop and go roll processing, both in the flip chip process, but also ICA bonding and low temp solders with reflow. Third and most versatile process is kind of combination or pick a bunch of different processes is related to the post-processing. So there's quite often lots of lamination, cutting, laser or die cutting, laser ablation, and assembly of parts that couldn't be done in the chip pick and place assembly, and of course the integration to materials like injection molding. But of course, realistically, this is a little bit simplified process because you need to always build the process, upscalable process, case by case. Then a little peek on what is the pilot factory and what it means, and it consists of facilities and machines for printing, assembly, injection molding,